This is the video lesson for Algebra 2, Lesson 1.3, Algebraic Expressions. So in this lesson, we're going to evaluate algebraic expressions and simplify algebraic expressions. So once again, this is a review of Algebra 1, probably a couple sections in Algebra 1 they throw into one section. So hopefully this is all familiar to you. The first problem states which algebraic expression models the word or phrase. We're just turning words into numbers, 7 fewer than a number t. So if you think about the English here, you're 7 fewer. That means this means you have 7 less than a number you already had. So you're starting with the t, even though it's written second. So it's going to be t minus 7, which is going to be c here. Okay, and now there's one for you to try on your own. Actually, I'll just do this one together because it's a little bit different than the other one. This says, which algebraic expression? 2 times the sum of a and b. So this is talking about the sum of a and b. Sum means plus. So this is going to be a and b in a parentheses. And then it's 2 times this. So you would do this first, the sum of this, and then multiply by 2. So this is 2 times the quantity a plus b, which is b. Okay, you probably could have done that on your own, but moving on. Problem 2. You start with $20 and save $6 each week. What algebraic expression models the total amount you save? Okay, so this is just starting us practicing going from word problems to solving them algebraically. In this problem, we want to model the total amount that you save. So each week, this is going to change, right? You're going to have a different amount each week. So that's going to be your variable. Whenever you do a word problem, you want to start with a variable. I always do X. You can do W for week. Maybe that helps you figure out what your variable means. In this case, I usually just use X. And the X, this is what's changing. So this is going to be, X is going to be number of weeks. Okay, so first you just want to write the algebraic expression, right? So total amount, so the total amount here is going to be 20, right? Because you start with 20. And then the amount you save is going to be, 6 times however many weeks there are. In this case, it's X. This is 6 times X. So this is our algebraic expression that models the total amount you save. And then there's going to be one here for you to try. You have $150, but you're spending $2 each day. What algebraic expression models this situation? So press pause, try this one on your own, and then check back for the solution. Okay, in this example, again, I have each day, the number of days is changing. So that's going to be my variable X. And then the situation is the amount of money you have after X days. And this expression can be written, you have 150, and then you each day you subtract 2. So however many days that is, it's 2 times that amount of days, and you subtract it from the 150, right? Because you're spending, you have 150, you're spending, that means minus. Okay, next thing we're going to do is sub in numbers for variables. So this is asking what's the value of each expression for the given variables, not variables, sorry, the given values of the variables. So here my A is -4, my B is 5. So let's rewrite this subbing in. This would be -4 and this would be 5. So we're going to rewrite this. You can see this goes to 0, -4 plus 4. And 0 times 7 is 0, so this just goes to 0. And then 3 times 5 is 15 minus 8, which is 7. Okay, that was actually kind of fast to do that. But let's do the next one. I'll do it a little slower. X is 1. So let's plug in 1 for X here. So we're going to rewrite this as 1 divided by 4 plus, and then Y is 1/2. So we're going to plug in 1/2 for Y. So this is 1/2 squared. Okay, and so then we're going to square this 1/2 first. So this is 1/4 plus, and remember when you square a fraction, you can square the top and square the bottom. So 1 squared is 1, 2 squared is 4. So this is just 1/4 plus 1/4. And with a fraction, we already have the two denominators the same. So our denominator is going to stay that known number. And then this is 1 plus 1, which is 2/4. And that they each have a 2 in it, right? We can divide this by 2 and divide this by 2. So we're going to reduce this. This is 1/2, so 1/2. Okay, so try these two on your own. You can plug in, maybe you don't need to see that. Let's do this up here. You're going to plug in 6 for M and N for -3 for both of these. So press pause and check back for your solution. Okay, so these ones, when you plug in 6 for M, and negative 3 for n, you get 12 for the first one and 30 for the next one. So if you got this wrong, just press pause and see if you can find your mistake. Okay, moving on. Okay, so now we're going to start with word problems, and we're going to be writing and evaluating expressions. So we're just going to take these slow. Let's read through this and see if we can write an expression for this and then evaluate it. So in football, a touchdown is worth 6 points, an extra point is 1, field goal is 3. So what algebraic expression models the total number of points a football team scores in a game? Okay, so we need a number of touchdowns. Let's call, I guess let's do X, number of touchdowns. Let's do Y, number of extra points. And let's do Z as number of field goals. So the first part we're doing here is what we're modeling total number of points. So total points. And just the expression is going to be equal to, 6 points for a touchdown, so 6x, 1 point for an extra kick, so plus 1y, and then 3 points for a field goal, so plus 3z. So that is our algebraic expression that models the total points for a football game or team and how much they score. So now, if we have a team, it scores 3 touchdowns, so my x equals 3. 2 extra point kicks, so y equals 2, and then 4 field goals, so z is 4. We just plug those in there. So the total points for this team is 6 times 3 plus 1. You don't normally write the 1, but just this one I'm just going to do because it's easier. And it's easier to see it, plus 3, and then 4 field goals. Okay, so this becomes 18 plus 2, which is 20, plus 12 is 42. Right, 20, 32. Sorry, that felt wrong. Okay, so this team scored 32 points. Okay, so try this one on your own. Read it, write an expression first. Remember, this problem is asking 2 different questions. This is the expression, and then this answers the question at the end. How many points did the team score? So there's 2 answers here. Let's do that here. Write your expression, and then how many points did this team score? Okay, press pause and then check back for the solution. Okay, so here's my 42. Hopefully you got that the expression was 2 times x plus 3 times y plus 1 times z, or whatever variables you had for your 2 point and your 3 point and your free throws. And then when you set that in and added them up, you got 42 points. Okay, here is a concept summary for this stuff. You can take a look at that. Some more properties. Okay, and then moving on to our last problem. Yes, last problem, combining like terms. This is just something you're going to practice from Algebra 1. Combining like terms is going to help you solve equations in Algebra 2. So remember, like terms are going to be if they have the same, not just the same variables, but also the same exponent on the variable. So here, and the numbers don't matter, right? So this isn't, there's 7x squareds and you lose 4x squared. So these two are like terms because of the x squareds. Right, so we can combine those. If you have 7 of them and you lose 4, you're left with 3x squareds. And then this is a y squared and this is a y squared. So we can combine these two, 3 and then 2. So this is plus 5y squared. And so that is our answer when you combine. Okay, so k and m would be like terms, j squared, k and j. J and j squared would not be like terms, right? These two are j squared, they can be like terms. Oh, sorry, this is the one you're going to be working on. Okay, let me do this one and then you guys can do this one on your own. I think there's a second one for you to do on your own too. Okay, so this is the first one. The second one, before you can combine like terms, you need to distribute. So remember when you're distributing a negative number, it's basically like a -1. So -1 times 3k is -3k. And then this one also gets the -1, so it's just -m. You don't write the 1. And then this one distributed, so this is plus 2k, and then 2 times -4m is -8m. Okay, now we can combine like terms. Our k's, -3 plus 2 is going to be a -1k, so we just write -k. And then my m's, -m minus 8m is going to be -9m. And so that is our simplified version of that expression. So distributing and then combining like terms. Okay, so try that on your own for these last two, and then check back for your solutions, and then we'll be done. Okay, here's your answer to C, here's your answer to D. Press pause and check yours if you didn't get the same thing, and then time to practice. Enjoy.